When you hear the word symmetry, what other words come to mind? Gabe?
The same.
The same. Anyone else? Same. Yes. Maybe a mirror, and so on. So our first starting point, our go-to when we're working stuff out, this is our home base, like in baseball, home base. We always want to get back to home base. We might travel around the circle, but we want to go back. So our home base is XY. Another way to say this is our point at an angle, which is this angle here. Could be 30, could be 40, 50, could be 51. Does not matter. Now remember, an X and a Y is now represented with an angle in it. But how do we write that, Nathan? What goes in front? Tim, cosine. And then sine. Once again, it's a re-expression of our home base. What I'm going to do now is, if this is this angle here, we have other versions of the same angle that we had in the first place. Okay, but for example, if I know that this is xy, what do you think that we can represent in terms of xy if this point is reflected over here? A negative xy, good sir. Has the cosine changed?
Yeah.
Has the sine changed? No. Let's go down here. If I have in x and y, what would these two be, Manny?
Negative.
Negative
X1
and
negative y.
And a negative y. And if I were to go here, Jesse, we have an x negative y. Okay. Now, if we were to write this as a point now, if this was the angle, what can I write in here if that is also the equal angle? How could I rewrite this in here? Because this is not theta anymore. What is it? Okay. What's our reference point over here?
1 pi.
It's 1 pi. Or 180. So therefore,
180 minus theta.
180 minus theta or pi minus theta. Okay. We refer from zeros, we refer from 2 pi's, and we refer from pi. Why don't we refer from pi on 2 or negative pi on 2? Why? Why don't we refer from them? Can anyone tell me? Have a look at where the angles are sitting.
Add from pi's minus from down there.
Okay, are you saying this the gap in between, Tim?
Yeah.
Okay. Would anyone like to add to Tim's?
Angle's closer.
Angle's closer? It's closer to here? That's one way to look at it. What else? Notice that our reference is between the line and the zero. The reference point has nothing to do up here. Therefore, we're not reading from this middle line. because this angle is from the reference of 0 or pi, and we're reading it backwards. So in a way, what we're doing, like a windscreen wiper in your car, we're going wiping all the way to pi, but then we go back. So we're going to pi, but then we go back. If that's pi and back, what's this one?
Pi plus theta.
A pi plus theta. This is pi and forward when your windscreen wiper's fallen off. Now it's on your hood. Okay? What about this one over here? How could we say this? 2 pi.
Minus theta.
A 2 pi minus theta
But it's minus theta.
and a minus theta. Good. We're picking it up. So let's go back up to here. P pi minus theta is this, is a negative x and y. Now think about it. Now let's have a double with cosine angle, sine angle. If that is cosine and sine, what is the version of it in cosine and sine, Zach? If this is cosine sine, the one over here, what is the variation? Negative cosine sine. Down here, pi plus theta. Let's write it down here. Zaid, what do you think our cosine and sines would be when we're down here with these as a clue?
Negative x and y.
A negative cosine
Oh, yeah.
and they
Negative sine.
and a negative sine. What about here, Maya? This one here. Cosine and negative sine. Good. Okay. And likewise, the same with the negative theta, which we'll get into in a second. We'll do that later. Okay, good. Now, just going to change 6. Anything else I need to say here? Let's go. I just want to pick on this for a bit. Let's say we gave you cosine plus pi plus theta. So we're in here. Okay. What is it in regards to x? What is it? This went down here. Cosine refers to what letter?
Okay.
But what type of x is it in here?
Negative.
So negative x. Okay.
Also negative versus.
Also negative cosine theta. We've gotten back to home base in a way. It's a negative version. If you see the clue pi plus theta, it's a version of cosine theta, but now it's negative. Okay, let's do this one. Which quadrant are we in? Remember? Quadrant 1, 2, 3, 4. Emily, which quadrant are we in? We're in 3. Sine, what's the version of it in x's and y's? It's a negative y. Good. And the negative sine theta. Okay, we're going to go again. If I asked you this one, pi take away theta. Which quadrant am I in, Nathan? 1, 2, 3, or 4? 1, 2, 3, or 4. We're going to pi, but we're going back. Quadrant 2. What is this in letters? That's okay. You're behind the lesson. That's okay. Nothing wrong. Zach, pi minus theta. What is it in letters? Cosine means what letter?
Y.
X, but is it positive X or negative X? It's a negative X. Okay. Let's go with this one. Barry, help me out with this one. Quadrant 2. It's a Y, positive or negative? Okay. And final, positive sine theta. Okay. It makes sense because just say if this was roughly a coordinate, if I had this 1, 2, and this was negative 1, 2, a reflection doesn't matter, it doesn't affect the y's. So that 2 is just a 2. Let's go again. 2. Finally, let's do this one. Sorry, I am going to buy some texters. Jesse, which quadrant am I? 1, 2, 3, or 4? I'm going to 2 pi, but then I'm going back. Correct. What's the letter? Positive or negative? Good. Therefore, goes like that. Okay. Last one. Just for a bit of practice. Okay. Go.
Uh, yeah, negative Y.
Negative 1.
And then it's got to be negative sine of theta.
Okay. So what we're doing now, we've got tools now. If I give you this, that looked like a lot of work, but it's really a negative version of the first quadrant of what we know. Okay. All right. We're gonna go. I just want to make sure we know what we're doing. So I'm gonna go do this. Let's see if we've caught on. So, are we okay in the first quadrant that everything's positive? Got a positive x, positive y, and a positive 10. Why is 10 positive? Okay.
Because the ratio is positive because sine divided by cos is positive. That's both on the side.
Okay. Now, let's look at this one here. I want you to write out what you think these are. This is going to get messy. Cosine pi minus theta, Manny. What type of cosine? Good. Sine pi minus theta, Zaid. What type of sine is it? Positive. It is. Okay. Tan, Perry. One's a positive, one's a negative. Therefore, tan is negative. It's a negative version of the original. Let's go down here. I'm getting really hot. Like this box. Okay, Jesse. Cosine pi plus theta. What type of cosine theta is it? It's a negative cosine theta. Zach. It's a negative sine theta. Nathan. Tan is really a sine over a cosine, but these two are negatives. So what type of tan theta is this? A negative divided by a negative? It's a positive. Okay, lastly. Tim, cosine 2 pi minus theta. What do you reckon? Good. Emily? Good. Iron? It is a negative. Okay, let's do some questions. I have no idea. So let's get some questions underway. Now, for the first thing that you need to do, we need to make sure what we're actually looking for. Are we looking for degree or radian?
Degree. Not radian.
Radian. There is no degree sign. So we're not calculating inside, we're calculating the length outside. Okay, so I have cosine pi minus x, but there is a starting clue. Cosine x, our home base, is 0.4. If our home base is 0.4, how can I rewrite cosine pi minus x? Where do you see this? Which quadrant is that? It's quadrant 2. Look, pi minus theta, it's pi minus x. But we figured out that it's a negative version of the original. So we just go negative cosine x. And what's cosine x? 0.4. Done. We use the clue. Let's get a b. Cosine pi plus x. What is it going to be, Perry? It's a negative cosine. Is that what you're looking for there? Okay, so once again, oops, negative 0.4. Okay, Jesse, cosine 2 pi minus x, which quadrant? 4. Okay, which equation are you going to use? We can see here. Therefore, what's our answer? Is it going to be a positive version of our home base or a negative? It's a positive. Okay. I'm just writing out the middle steps so you know what's going on. And Zach, cosine negative x. Which quadrant?
It's the exact same thing.
It's exact, yeah. Why, Zach, why is it the exact same thing? Because 2 pi is 0. Yeah, it's the same. Okay. Okay, 0.4. Okay, you've got 30 seconds to do these ones, please. These ones are in degrees, and I'm going to ask you, be prepared with your answers. You can get a piece of paper out. This one here, let's do sine. This is now degrees. Because yeah, this is where it gets a bit, it could potentially get a bit confusing. Okay. I just want you to, this is really a coordinate. Okay. So I want you to, we're using degrees now. In now working out. So have we got these? Good. Okay, I'll give you a moment. Point 0.7 is a coordinate. What we're saying here, if point 0.7 is here, this is 0.7. Oh, hang on, 0.7. This is it. That's what we're really saying. 0.7 is a coordinate along our unit circle. So if I go up to here, my y, if this is a 1, 0.7 reads across as our y. But we're using the degrees, the center, to look at symmetry. Which quadrant am I at, Emily? Quadrant 2. So how can I simplify this now? So it's just sine of x, good, and it's just 0.7. Okay. 180 plus pi Maya. Which quadrant? 3. What type of sign is it going to be? It's a negative sign. Okay. So we just whack a negative on our answer. Okay. Okay. Sine 360, take away x. Which quadrant? 4. What type of sine x is it? It's negative. Negative 0.7. Tim? Yeah. It's the same thing. Just written differently. Okay. Any questions with that? All right. I'm going to give out your sheets.